So I'm trying to get back to some programming on a project of my own, personal projects. And I was up till 6 a.m. last night working on it. And I want to get back to it, but then again, I don't want to fuck my code up. I'm working on some 3D math kind of stuff, which gets a little confusing. I can follow the math, but gets confusing after a couple rotations in. Rotate from this to this, and then this to that, and then don't forget this, and then oops, this is y is in the negative direction on the screen. So, and all the math equations that you look up, it's like some of them use x and y and z, and my x and y and z are different. I have to remember that my z is its x, and its x is my y, and this is negative, it's this. Ugh. But went really well because I just have this little 2D graphics that I was drawing, and I'm using this thing called Pajamas that does it all in the browser. You write a program in Python, and it actually compiles it. Instead of a machine language, like for a machine, it compiles it into JavaScript and can run in the browser. So you can make a full-on Python app. And it's got this great GWT toolkit is converted to use for Python. GWT is for Java, but it's what Google uses for Google Maps and stuff. And it's really amazing. And I was realizing this stuff is fast enough. People say they do little transforms, and I don't want to do a full-on 3D thing, but I'd like to draw this stuff, and I thought, well, I could do it isometric. There's lots of little 2.5D kind of ways old school ways to get a 3D kind of a thing. And I realized for this basic part, though, I could just do a perspective transformation, and boom, 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 it all works, and it's fast enough. It's amazing. I really love this stuff. It's too bad about if Google's getting evil, because that's some good stuff there. They've got between their app engine and this Pajamas Ajax stuff. So anyway, yeah, that's what I really love coding. When you're programming, what you do is if you're me, is you pretend that you're a computer. And you can only do what a computer is. Like, you're a human, but you're inside a computer, and you can only make the computer behave with certain behaviors. And you have to reduce yourself to those behaviors. It's like driving a remote control. You can't just move the car. Well, you can, but that's cheating. You got to pretend you're in that location, and backing up means backing up over there, not backing up from where you are, and you put yourself into that. And you do that with computers, and it's really always been a wonderfully relieving thing, because it's just the attitude that you have to take to think like the computer, but then accomplish something human, like a game or a tool or something like this. And I was really fortunate when I started to learn computers back in the mid-'80s, because I got an Apple IIe. I had to buy half of it. My parents bought the other half for me, and worked a summer job. And well, I've been working since I was 13, summer and school. But anyway, and I was fortunate because it had a really simple processor, and I learned that processor, and so I have in my mind, an understanding of how it goes all the way from the machine level, where everything's numbers. In the physics I've studied, I understand how it's not really even numbers, it's just a bunch of electrical lines, millions of electrical lines that like a switching network, that you can turn into numbers, and the numbers is what you get at the programming language levels, numbers and just like whatever the 5 basic logical concepts and procedural logic, and and between those two things you can make metaphors for all kinds of other stuff. It's like, how are you going to make a computer program be like a typewriter? It's all numbers. How are you going to have it draw graphics? Well, colors are numbers, letters are numbers. It's just amazing how you can use the quantification metaphor so generally. And there's many things it doesn't fit for, and you can still use it. I mean, you can't quantify love, but it still works in The Sims to make for a simulation of something like love. It's not real love, but then you can still kind of get at it. I was thinking of all the great things I programmed over the years. I've been programming for 30 years. I learned how to do assembly programs 6 months after I started. I started with BASIC and then I learned assembly for the 6502. I think it might have been a 6502A. And, so that's a lot of programming from the machine's point of view. I've enjoyed making a lot of things. When I was young and I worked for NASA Ames, I learned C programming. I did a lot of cool stuff there. I did some projects on my own that really, in that period, that really helped form how I program. I remember learning about object-oriented coding, and I was coding in C, and I just got the idea of bundling the functions in the data, and I realized that I wanted to start calling things by function pointers, and I had done a little program, just traditional style, that drew a little spinning line, and it would bounce off the edge of the screen. It's kind of like it would be a screensaver or something, but it wasn't meant to be a screensaver. And then I made it on these other principles, and instead of having just this one structure for the line, I broke out everything, all the functional things. I had a function to change the rotation, therefore I had data that was just rotation in its own data structure. And it was amazing because the program was easier to write, and it was a lot more powerful. Instead of just one baton bouncing around, I could have that baton break into two. I could have the rotation, change back and forth. I could, and this was all in C, but with kind of an object-oriented idea. So those things were really good. And by the time I moved into commercial software, I had a very good understanding of that. I think I understood how to make plug-in systems, before they made plug-in systems, when only really device drivers and things like that were loaded in this configuration-driven way, because of all this kind of indirection in my C experience. So another thing I was working on a virtual environment around 91, big, like quarter-mile square area. Graphics looked kind of like the Sims, that style of size of human, but it was a full free 6-degree freedom of motion 3D engine. And I was working on the artificial intelligence libraries and the client software. I made there a plug-in system. It was cool, so that we had this virtual environment. Let's say you wanted to add something to it. You wanted to add a hammer. So, well, you need a hammer and nails and boards. That's let's say for this little kit. And it has code. It's got art. How do you have a client that can load that? And obviously we all use plug-in systems now. It's pretty straightforward. But we had an idea that would have been much worse, well, you rebuild your program and you ship it again, and that's the next version. But I made this thing called the extensible instantiator that was able to do it such that if you had a new set of objects that worked together like that, you could just download a DLL. This was for Windows, and suddenly it would appear, all the art, its special code, everything would be integrated. That was cool. The other cool thing for that was the end when I was making the behavior server, as I would refer to it, where we logged in various characters. Like there was a garbage bot that would go around and pick up garbage, because you could have food and drink in this place, and then you drop it, all kinds of garbage, and it would walk around. And there was a tour guide and a fortune teller and whatnot, like so. The garbage thing was really interesting because I had a sort of an epiphany in my life, because I was trying to get this garbage bot to clean an area, and my problem is that it would go to the edge of the area, and then there would be a little bit of trash just right beyond its area, and it wouldn't go get it. It's very hard to make a logic of stay in this area and do this. Oh, but go ahead and go out of the area if you want. And it could get caught and things like this. It's like, Well, it couldn't get caught, sorry, but it could get in some cyclic pattern if you have a rule that works because it's strict, like stay in this region, but no, you could go out of it. So I had all these ideas of how to hybridize that. And I realized I'd really need a way of programming their ideas. as well, but that's another issue. But partially because of the way I did arrange the artificial intelligence functions, um, but also just as a general thing, I learned that to make a robot clean up a certain area, because you don't want it to wander out of that area. If it always just gets the closest piece of trash, that's another option. It'll wander out of there, and it might even get clustered over in some part. All the garbage bots would cluster out, which is why I wanted to keep it. Here's your area, keep this area clean. And I found out the way to do that is just give it a home point. Every certain period of time, send it back to its home point. It can wander as far away as it wants and then send it back. And it was just so obvious. I mean, I'd spent so much time trying to kludge this other rectilinear way. And you see, it's kind of a metaphor for life to me, because it's always better to have a home point than to have a boundary. The safety that one gets from home is that there's a home point, as opposed to that there's a boundary you can't cross that keeps you near the home point. Returning to home is the way to claim a territory rather than draw a line around it. And so I believe those things, and then it turned out algorithmically to be true as well. Another thing I really enjoyed making was this octal tree thing for yet another 3D virtual environment. There's problems where, you got thousands of people in a space. You got to tell someone about all the, let's say, 500 people around them or objects around them. How do you know where they're, how do you find all the things that are around them? Now, if you just have a big unordered set, then you have to go through everybody, find out, do radial calculations. That doesn't really work. A brute force idea would be to partition your space into voxels, so 3D pixels, and someone occupies a location, you just go to that location. But also the math there can be kind of nasty, but it improves the math. But the main problem is the bloat. You don't have enough memory if you want like your coordinates down to the centimeter for something like that. So with an octal tree, what you do is you take an area, and let's say some guy is in an acre, but he's just all alone, walk around there. There's a coyote out there. And so you have these two things in your database. Well, you don't need a lot of different slots. You only need one, actually. You can keep them both in one queue. So basically, you keep this cube. If the cube has less than whatever, a few hundred people in it, then you just keep it as is. But when the cube gets overcrowded, let's say there's 1,000 people, by then it's going to have split. And what you do is you always take a cube and you split it into 8 subcubes. If you understand what I'm talking about, like 2 layers of 4 subcubes. And it's half as big. And what you can do is, however crowded things get, you can break these down. And then in each of those cubes you have a list, and you put the player objects and things on this list. And then the coordinates of that object can be as high res as you want. But what you've done is, when you're trying to find out the neighbors of that guy, you immediately go to that list, because those are the best candidates. Now, somebody in his area might still be out of seeing range, but you have only a small list of people to check. And then the real fun part was that I invented an addressing scheme for the octree where I could do string processing. You give me the address of a particular node in this tree, and I could do string processing to figure out the addresses of all the neighbors, because you have to do that in the neighbor, because maybe I'm in the cell because of my actual cube region of space with this coyote, but I'm at one end of the cube, he's at the other. I might be closer to something in a neighboring cell, so I do have to check the neighboring cell. So that was really fun. I enjoyed that kind of stuff. But anyway, yeah, I think I'm going to get back to some coding, but I might get a couple videos I've been wanting to make out of the way. Alright, cheers. When I stay up till 6 coding and I don't even make a YouTube video as a break, I'm getting very into it. I love logic.